Hello and welcome to one of my C# lessons. Our lesson today will be about parallel loops. Here is the content of my lesson today. I will describe the difference between the standard and parallel loops. Then I will show you the for loop with an example in both standard syntax and parallel syntax. Then I will show you the same with for each loop. After that, I will show you how to break parallel for loops. Finally, I will show you how to use the result value of parallel for loops. Let's first understand the difference between standard for loops and parallel loops. The standard for loops are built-in statements in the C# language, while the parallel loops created by a .NET class defined in System.Threading namespace. The standard for loops run sequentially, while parallel for loops runs in parallel. The standard for loops run on the same thread, while parallel loops runs under multiple threads. Each loop will be running on its own thread. The standard for loops have C# break statement to stop the loop, while parallel loops have two different methods to stop the loops. Parallel class is defined in System.Threading namespace that can be used to create loops that runs in parallel. These loops can replace the built-in for and for each loops in C#. The normal built-in loops run sequentially, however, the loops created by parallel class runs in parallel, which means that multiple iterations can run at the same time in multiple threads. This process can increase the performance of your application greatly in some situations. Generally, when the iterations do not depend on each other and execute code that takes a considerable long time, then using parallel class can enhance the performance of your application. The best way to tell if you really need the parallel loops and not the standard loops is to measure the performance of your application with and without using the parallel class and decide yourself. Let's see the syntax of writing loops using the parallel class. I will first write a normal for loops with the standard C# syntax. Then I will convert it to a parallel for loop. I will type for with a variable named n and 10 million iterations. To write the same loop using the parallel class, I will type parallel.for, and note here that for is written with a capital F. The first parameter of this method is starting value, which is 0 in our case. The second parameter is the loop iteration ending condition, which is 10 million here. Note that the first parameter is inclusive, which means that n in the first iteration will be 0, while the second parameter is exclusive, which means that the last iteration n will be 1 less than 10 million. So this loop will execute for n values from 0 to 9,999,999. The third parameter here is an action type, which can be written as lambda expression containing the loop body. I will type n equals greater than, then the code braces. Now we have two identical loops. The only difference is the iterations of the first loop will run sequentially, while the iterations of the second loop will run in parallel in multiple threads at the same time. I will write a statement here to convert the n value to string. String converted equals n dot to string. I will copy the same line to the second loop here. To measure the time consumed by both loops in order to be able to compare the performance, I will use the stopwatch class, which is defined in the System.Diagnostics namespace. I will define an object here, stopwatch, SW equals new stopwatch. Before the first for loop, I will start the stopwatch by typing SW.start. After the loop, I will type console.writeLine standard for loop takes and the stopwatch object elapsed milliseconds. Before the second for loop, I will restart the stopwatch sw.restart, and again after the loop I will type console.writeLine parallel for loop takes and again sw.elapsed milliseconds. Let's run the application now. You see the results here. There is a big difference in execution time between both loops. The standard loop took about double the time the parallel loop took to execute. We are doing a simple task here and the parallel loop was much better, but when it comes to actual longer and more complicated code being executed, you may find the parallel loop executes faster or slower than the standard for loops according to the code being executed. You can judge it and select the suitable loop according to the situation. Okay, let's see the for each loop. I will create an array of strings here that holds some website URLs. I will iterate through this array as a collection using both the standard for each and parallel for each loops. I will start by array declaration string array URLs equals, and between the braces I will initialize this array with some URLs like www.google.com, microsoft.com, visualstudio.com, amazon.com, youtube.com, facebook.com, and finally twitter.com. I will create a standard for each loop, for each string URL in URLs, then the braces. I will create the second loop parallel dot for each, and note again that F is capital here. Then I will pass the array as the first parameter to this method, and the second parameter is my action, the lambda expression, URL equals greater than, then code braces. Before each loop, I will restart the stopwatch sw.restart, and here also sw.restart. After each loop, I will print the elapsed time console.writeLine standard for each loop takes sw.elapsed milliseconds. Here also I will print console.writeLine parallel for each loop takes sw.elapsed milliseconds. Inside the for loop, I will download the homepage HTML for each of these websites, I will type here HTTP web request my request equals HTTP web request dot create URL. Then my request dot method equals get. Then web response my response equals my request dot get response. Then stream reader SR equals new stream reader my response dot get response string, comma encoding UTF-8. Here I will get the result string result equals sr dot read to end. Then I will close the stream sr dot close and close the response my response dot close. I can type the results, but since the HTML page will be very lengthy, I will just type the first 10 characters of the result to the console. Console.writeLine result.substring of 0 and 10. Now this code is ready. It will simply download the web page and then print the first 10 characters of the HTML page. I will simply copy this code to the other loop. Now let's run the application. We can see the difference here in the favor of the parallel for each loop against the standard loop. However, the results may not be fair enough since my computer or nearby servers may be caching the websites from the first request in the for each loop, and when calling again using the parallel loops, it may be coming faster from this cache. So we can interchange the code blocks of the loops here and run the application again. Okay, the application now will give you different results, and if you run each time, you may get different results according to the situation. You can increase the list of websites to get more accurate results. Generally, as stated earlier, in actual situations, you should check the performance and select the better solution. Okay, now let's talk about something else here. The breaking mechanism. In the standard for loop, the break statement is used to stop processing of the standard for and for each loops in C#. When using parallel loops, a similar mechanism exists through the parallel loop state class. If I need to stop the first loop, for example, when the counter variable reaches 5, I can type in the standard for loop fn double equals 5 and break statement. To do the same in the parallel loop, I need to first replace the standard action that takes only one parameter with another action that takes two parameters, integer type and parallel loop state type. So I will change the definition of the action in the lambda expression to be n, state. Inside the loop, I can type if n double equals 5, then call the break method of the state object. I can do the same with for each loops with suitable conditions. Let's run the application now to see the results. Great, it worked fine. You should understand that since the parallel for and for each loops runs in parallel, some iterations may be executing when you execute the break method. Break method, when issued, will make sure that no additional loops will be created. However, it will allow all iterations that are currently running to complete its job till the end. There is another method of the parallel loop state class called stop. This method will stop all loops from running even if their work was not completed yet. We can replace the break method with the stop method here and run again. This time, although the processing is still done in parallel, but when the stop method reached, all current running loops will stop immediately. Both parallel for and for each loops return a value of type parallel loop result. It is a struct data type having two important properties we can make use of when breaking loops. Is completed property, which indicates if the loop runs till end, including all iterations, or it was exited before completion using break or stop methods. The second property is lowest break iteration, which indicates the number of iterations completed by the for or for each loops before breaking. This property is available only when the break method is used. It will have a null value if all iterations completed or if we used the stop method. Let's try them. First, I will change the call line of the parallel for loop to keep the return value in a variable. So here I will write parallel loop result for result equals and keep the remaining of the line. You can use the same syntax for parallel for each loop. Now we have a variable containing the return value of the parallel for method. Let's try printing the properties values of this return value. Here I will type console.writeLine for result dot is completed, then console.writeLine for result dot lowest break iteration. I will run the application now and see the results. You can see here that the completed property is false since I am using a stop method here, and the lowest break iteration is null because I'm using a stop. If I change the stop method to break, I can see the results here. Is completed is still false as not all iterations completed, and lowest break iteration is showing the number of completed iterations here. If I removed the break statement, I can see the results here again. Is completed is true because this time I have not stopped the iterations at all, and lowest break iteration is null since I have not used the break method. I think the concept is clear now. You can find the final project in the folder Parallel Loops inside my repository named C# lessons in my account on GitHub. The full address is displayed here, github.com/ehab/c#lessons/3/master/parallel loops. Thanks a lot for watching this video, and I hope it was beneficial to you. If you want me to create other videos, please leave a comment and I will try to create videos on concepts with high demand. Thank you and goodbye.